Okay, so we will continue with 7.3, which was Cramer's rule. Okay, and actually, what we're going to learn today is the Cramer's rule itself. Okay, yesterday we talked about matrices and determinants, and today we're going to talk about how to use the Cramer's rule to solve systems of linear equations. In this case, 2 by 2. That means two equations in two variables. Okay. And I'm going to write the equations here. 5x minus 5y equals minus 15, minus 2x minus 4y equals 0. Okay, this is the system, and what we do here is the following. First, we need to build the determinant D. Okay, well, before doing that, I need you guys to realize that this system is actually it's made out of three columns. Okay, it's made out of three columns, which are this column is the x coefficients. Okay, I'm talking about the numbers. Okay, we ignore the variables. The coefficients of the x, which are 5 and minus 2. In this column, we have the coefficients of the y, minus 5 and minus 4. And in this one, we have the independent terms, okay, which are minus 15 are 0, okay? And we're going to use those three columns to build our determinants. So the determinant D is composed by these two columns, okay? The columns of the coefficients for x and the columns of coefficients for y. So 5 minus 2 minus 5 minus 4. And I'm going to solve this determinant, okay? So this is 5 times minus 4. This is minus 20 minus 5 times minus 2, which is 10. Okay, so this is minus 30. Yes, okay, minus 30. Okay, 5 minus 2 minus 5 minus 4. 5 times minus 4 is minus 20 minus 10. Okay, it's okay. Good. Then this is the value of the determinant D. Okay, so now what we're going to do is, in order to find x, x is equals a fraction which has in the denominator has this value, and on the numerator has a determinant which is this one, but replacing the column of the coefficients of x. Okay, I'm finding x, so I replace the first column. Which values do I use? This column, the third one. So now it's minus 15, 0, and the other column remains the same. Minus 5, minus 4. Okay, so I have to solve this. And this is minus 15 times minus 4 is 60 minus 0, because 0 times minus 5 is 0. So this is 60 divided by minus 30, which is minus 2. So x equals minus 2. And now let's find y. Okay, and it's the same procedure. So for y, the denominator is 30 again, but the determinant changes. The first column is like in the original determinant, 5 minus 2, but it's the second column, the one that changes. And now instead of using minus 5 minus 4, I'm replacing it by the independent terms. Okay, so now this determinant is 5 minus 2, 3 minus 15, 0. And this gives me 0 minus 2 times minus 15 is 30 positive. And this is minus 30. So this is going to be 1. Okay, minus 30 divided by minus 30 is 1. Okay, and this is how I solve a system of two equations in two variables using Cramer's rule. Okay, so solving determinants. I'm going to stop recording now. Well, before I stop recording, sorry, I forgot to say, and I want this to be recorded, that in this first step, okay, when I find this determinant, in case D equals 0, the system has either infinitely many solutions or no solution. Okay, so in order to know that this system will have one solution, so it's a system which is consistent and independent, we need to have D equals a value different from 0. If D is 0, the system has either infinitely many solutions or it doesn't have a solution. Okay. I'm going to stop recording now.